Coming back to the solar system, it is really important to try to kind of make an inventory and understand the contribution from each component, for example, to the total mass. For example, it is important to understand that the sun really dominates the mass. It's almost 100% of all the mass, and the planets only constitute about 0.1%. The rest is in the form of dwarf planets, satellites, asteroids, comets, meteorites, but also some dust and even solar wind. We already mentioned this, but it's important to point out that essentially all the planets orbit the sun in nearly circular orbits. Mercury is perhaps the exception. Mars is also a little bit eccentric, but not as much as Mercury. They all orbit essentially within 10 degrees of Earth's orbital plane, so they're essentially all in the same plane as well, and all rotate essentially in the same direction, except Venus. And we won't go into details, but we expect that Venus rotates the other way around because of an early collision with a big object that actually made it stop spinning the way it did and actually start spinning the other way around, but really slowly. You will not have to know all the properties of all the planets for 263, apart from understanding at least the basics, that there are two big classes of planets within the solar system: the terrestrial planets, Mercury, Venus, Earth, and Mars, which are rocky, they're denser, smaller, and they're actually much closely spaced. They are the closest to the sun. And the gaseous planets, covering Jupiter, Saturn, Uranus, and Neptune, which are gaseous. They're much larger. They're mostly made of hydrogen and helium because they were able to hold on to them. Essentially, the temperature was low enough that their escape velocities was not exceeded. They're way less dense, and Saturn would even float on water. They're larger, and also they're further apart.